Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 27, Nature of Solutions of a System of Linear Equations. So in this video and in this lesson, they're not asking us to graph, they're not asking us to find solutions, all they're asking us is there a solution or not? Nature of solutions. So all we're really focusing on in this exercise here is determining the nature of the solution. Means, is there one solution, no solution, and why? Okay, so first thing I'm going to do is I have 3x plus 4y equals 5. Again, I've done this in previous videos, but if I have ax plus by equals c, and I want it in slope-intercept form, I need to move this ax over to the other side by subtracting ax from both sides. And when I do that, I get by equals a negative ax plus c. And then to get y by itself, we divide by b. And we need to do that to every part. The b's cancel on this side, and I get y equals negative a over b plus c over b. So m equals a negative a over b, and my y-intercept equals c over b. Okay, so these are the two things that we are focusing on. If it is in slope-intercept form, so I'm just going to state what the slope is and the y-intercept in each of these, and we will determine how many solutions by that. So 3x plus 4y equals 5. If I use my little formula over here, m is negative a, negative 3 over b, which is 4. So the slope of this one is negative 3/4. And the slope of this one is obviously negative 3/4 because it's already in slope-intercept form. So this is m and this is b. And as you can see, the b's are different as well. B in the first one is, remember, y-intercept is c divided by my b. So this is c and this is b. So the y-intercept is 5/4. And in this one, the y-intercept is 1. So they're different. So this is no solution. We have parallel lines. Okay, and that's what we're going to be doing. We're going to use this m equals negative a over b and c over b for the standard form. And the slope-intercept form, the slope and the y-intercept are staring us right in the eye. Okay, so here's number 2. Standard form, standard form. So m equals negative a over b. And then the second one, m equals negative a over b, which is negative 1. So the slope of this is negative 7/2, and the slope of this one is 1. So obviously negative 7/2 and 1 are different. I don't even have to check my y-intercepts, because these lines are not parallel, they're intersecting when the slopes are different. So this one, the slopes are different, therefore, 3 little dots in math mean therefore the lines intersect. And there is one solution. Okay, next one. This one here. Slope, these are both in standard form, so I need to do negative a over b. Negative a is negative 9 over b, which is 6, which reduces to negative 3/2. The slope of the first one is negative 3/2. This one here, the slope is negative a over b, which is 2, and obviously they're the same. And if I continue on and verify that these lines are not equal and sitting on top of each other, in other words, coincide, then I need to do my c over my b, which is 3 over 6, which is 1/2 is the y-intercept of the first one. And in the other one, my c over b is 1/2. So in this one, the slopes are, the lines of the graphs are the same. So when that happens, when slope and y-intercept are the same, the lines coincide. Therefore, infinite solutions. Okay, number 4, it says to determine the nature of the solution of each system, determine if there's no solution, one solution, or infinite, and if the system has a solution, find it algebraically, and then verify that your solution is correct by graphing. Okay, got a lot to do here. Okay, so here we go. I'm all set up here. I've got my graphs pulled in, and let's do this. So these are both in standard form. So slope equals negative a over b. Remember up here, negative a over b. So negative a is 3, so a negative a, or negative 3, over b, which is 3. So the slope is negative 1. On the second one, negative a is again negative 1 over 1. So the slopes are the same. So we have equivalent slopes, and now we need to find the y-intercept. So it's this number over that number, c over b, which is negative 21 over 3, which equals negative 7. And in the second line, my b is negative 7 over 1, which equals negative 7. So the system has a solution, so I need to graph this. So if I plot the red one, the y-intercept is negative 7. So I go down 7. There's my y-intercept at, this is the point negative, or this is the point 0, negative 7. And I have a slope of negative 1, which means go to the right one, down 1, right one, down 1, and so forth. Left one, up 1, if you will, and just keep going that way. So then when I go get my ruler and bring it down here, there's my line. So this is the line 3x plus 3y equals negative 21. Now when I go to graph this one, as you can see, the y-intercept is also negative 7. My slope is also negative 1, so I go down 1 over 1 and so forth. So when I bring that line back, there's the graph of the second line, and those are coinciding lines. They sit on top of each other. Every point you can choose, there is a solution. So there are infinitely many solutions. It says if the system has a solution, find it algebraically. I kind of skipped that step. So to find these algebraically, we are going to well, there's many ways we can do this. I am going to solve for y. We haven't done this yet, so I'm going to take 3x plus 3y equals negative 21. I'm going to subtract 3x from both sides, and I get 3y equals negative 3x minus 21, and divide both sides by 3, and divide both sides by 3, and I get y equals negative x minus 7. So if I do the same for this one, x plus y equals negative 7. Subtract x to get y by itself, and I get y equals negative x minus 7. So when I take those two equations and set them equal to each other, because if two things are equal to the same thing, they're equal to each other. That's a transitive property. If a equals b and b equals c, then a equals c. So I can say negative x minus 7 equals negative x minus 7, and when I add x to both sides, they cancel, and I get negative 7 equals negative 7, and that is always true. Okay, so since we have to solve these algebraically, I might as well just put them in slope-intercept form each time. So the first one is already in slope-intercept form. So I have y equals 3/2 x minus 1, where m equals 3 over 2, and my y-intercept is negative 1. So then I'm going to take this graph, or this equation, and solve for y by dividing both sides by 3. So this cancels, and I get y equals 1/3 x plus 2/3. So my slope is 1/3, and my y-intercept is 2/3. So obviously the slopes are different, so we're going to get a solution. So I'm going to solve these algebraically by setting them equal to each other. Since y equals 1/3 x plus 2/3 and y equals 3/2 x minus 1, then 3/2 x minus 1 is equal to 1/3 x plus 2/3. Okay, so I see 2's and I see 3's, and I don't want to deal with fractions. So 2 and 3 both go into 6. So I'm going to multiply everything by 6. So 6 divided by 2 is 3. 3 times 3 is 9x. Minus, so I'm distributing. 6 times 1 is 6. Equals, when I distribute here, 6 divided by 3 is 2. 2 times 1 is 2x. And then when I do that here, 6 divided by 3 is 2. 2 times 2 is 4. So I multiplied everything by 6 to get rid of the fractions. I'm now going to get all my x's on one side by subtracting 2x from both sides, and I get 7x minus 6 equals 4. Add 6 to both sides, and we're getting closer and closer to finding out what x is, and divide by 7, and x equals 1 3/7, or 10/7. So if I plot that point, that's my x value. I've got to plug that back into one of these equations. All right, so I'm going to leave it 10/7. And I'm going to substitute that in for x in one of my two equations. I'll do the 3y minus x plus 2. You can substitute this value into either of these two equations to find your y value of the point where they cross. So if I take 3y equals x plus 2, and I don't want that 7, so I'm going to multiply everything by 7. I get 7 times 3 is 21y equals, the 7's cancel, I get 10, plus 2, actually there shouldn't be an x there, 10 plus 14, so 21y equals 10 plus 14 is 24, divide by 21, and I get 1 3/21. Okay, instead of doing this here, I'm going to reduce, because 3 will go into each of these. 3 goes into 24 8 times, 3 goes into 21 7 times. So I have the point, my x is 10 over 7, and my y is 8 over 7. Okay, so y equals 8 over 7. So 10/7, 8/7. Well, 10/7 is 1 3/7. That's my x, so it's like right here. And then 8/7 is 1 1/7. So I would say that that point is approximately here. Okay, so that's where this point here is. That's where they intersect. So let's now graph these points. And I'll graph this one in black. So my y-intercept was -1, which is right here. And my slope was 3/2, which means go up 3 and right 2. So 1, 2, 3 over 2, and I'm right here. And then when I bring my ruler down to draw my line through those 2 points, there's the graph of the first line. Okay, so I was just off a little bit here. It's right there. That's our solution. And now I want to graph 3y equals x plus 2, and that simplified down to 1/3 x, so that's right here. 1/3 x plus 2/3, I'll do that in red. So my y-intercept is 2/3, so up 2/3 is approximately here. And rise 1, and then go over 1, 2, 3 is right here. And then when I bring my ruler over, and this is where being accurate with your ruler is really important, because that's how we find where two lines intersect. Okay, so again, it's hard to find approximate fractions like this, but now you get the idea as to where the solution to those two equations are. Okay, number 6. Okay, in number 6, it says x equals 12y minus 4. So I'm going to get it in slope-intercept form. It's just easier. So if I have x equals 12y minus 4, I want to get y by itself, so I'm going to add 4 to both sides. And I'm going to get x plus 4 equals 12y. Now I'm going to divide by 12. And when you divide by 12, everything gets divided by 12. And these y's, or these 12's cancel, leaving y equals, and I get 1/12 x plus, and that reduces to 1/3. Okay, so I'm going to rewrite that. I'm just going to reverse the sides. Y equals 1/12 x plus 1/3. So there is the slope-intercept form of my first equation, where my slope is 1/12 and my y-intercept is 1/3. Okay, so now I'm going to graph this one, or I'm going to convert it to slope-intercept form so we can graph it. And I'm going to show you how to solve this in a moment to find the solution without converting it, but we need to convert it to this to plot points. So if x equals 9y plus 7, and I want y by itself, I will subtract 7 from both sides, and I get x minus 7 equals 9y. Now divide everything by 9, and this 9 and this 9 cancel, leaving y equals 1/9x minus 7/9. So there's my equation. Actually, let me rewrite that. Okay. So I'm going to rewrite this as y equals, I'm just switching sides of the equation. Reflexive property. Okay, so there it is, y equals 1/9 x minus 7/9. Not very nice values to try to graph, but anyhow, now let's solve this by setting each of these equations equal to each other. Since they're both equal to x, they're equal to each other. So I can say 12y minus 4 is equal to 9y plus 7. Okay, if I subtract 9y from both sides, I get 3y minus 4 equals 7. Add 4, add 4. 3y equals 11. Divide by 3, divide by 3, and y equals 11/3. So that's going to give me a point something, comma, 11/3. And I now need to find my x value when y is that number. So I'm going to plug that into one of these two equations, and it doesn't matter. I will plug it into the 9y plus 7. So if I substitute that in for y, then I would now do the equation. Let's see, I haven't used black yet. So I'm going to use x equals 9y plus 7. But y is 11/3. So x equals 9 times 11/3 plus 7. So x equals, well, these 9's and 3's reduce to 3. 9/3 is 3 times 11 is 33 plus 7, and x equals 40. So I have the point 40, comma, 11/3. All right, so obviously we need to take that into consideration when graphing. So if I need to go way out to 40 on my x-axis, 5, 10, 15, 20, 25, 30, 35, 40, 40 will be here. So I'm going in units of, every square is going to be 5 wide. And so I don't clutter, I'm going to just label every other one. But going up, I only have to go to 11/3, so I can always just go by ones here and just show a few values so that your reader knows what your scale is. Okay, so now I'm going to plot these two lines. So if I graph the purple one here, y equals 1/12 x plus a third. My y-intercept is 1/3, so this is getting cut into 3, so it's right here. A third's approximately right there. And my slope is 1/12, which means I go up 1. So if I'm going up 1 from a third, I'm up to 1 and a third. And then I go to the right 12. Well, here's 10, here's 15, so 12 is about right here. Okay, so these are kind of approximations because it's tough to graph accurately when you have these types of numbers. I wish they would have chosen more user-friendly equations to introduce this concept, but anyhow. So there's my equation, x equals 12y minus 4. So I label it. Now I'm going to graph the other one in red. My y-intercept is -7/9. That's almost -1, which is right about here. And I'm going to go up 1, which is +7/9, or actually +2/9. And then I'm going to go over up, so I went up 1, and over 9 is just before this 10 right here. So there's the values I need to graph here. So when I do that, doesn't look like my lines are going to cross. Let me look at this again. Okay, so my purple line is off a little bit, so let me get rid of it. And I'm going to have to rewrite that because keep in mind my solution is 40, 11/3. So if I go over 40, 9/3 is 3, and then 11/3 is 2/3 more. So this is where my two lines should intersect. So when I drew my line through these two purple points, my slope was off a little bit. So this is really difficult to graph, but if you notice, if you adjust this, the points are so close together it was hard to draw. But actually, if I redraw that now, the line is still going through those 2 points here and here, and going through my solution, which is right there. Okay, so now I'm going to graph this point, this line, which is here, and I need to make an adjustment to my ruler. And I need to go through that point there and those two as well. So here is the line x equals 9y plus 7. So as you can see, these two lines do eventually cross at 40, 11/3. Okay. Number 7, write a system of equations with 4 and -5 as its solution. Okay, so if I'm going to do a system, it looks like this. And I'm going to make it really easy by just saying y equals, and I'm just going to make up a slope. How about 4x? Now I'm going to take this x here and plug it in here, so that's 16. This would equal 16, so in order for y to be -5, I have to subtract 21. So 4x minus 21, when I plug 4 in, I get -5 for my y. So that's one equation. And then another equation would equal, now I want a solution, so I'm going to change the slope to 3x. And now when I plug in x here, that's 12. Well, in order for me to get a -5, I have to subtract, from 12, I have to subtract 17. So I have 4x minus 12. and 3x minus 17 will give me these xy's. 4 times 3 is 12, minus 17 is negative 5, and 4 times 4 is 16, minus 21 is also negative 5. So there is a system of equations with a solution for negative 5. Okay, that is the end of lesson 27. Review the lesson summary and go do your problem set.